Moving to cloud, it's a brilliant opportunity. And when everyone started, we were promised a multitude of benefits of doing so, right? So it could be cost-effective solutions, it could be flexibility, etc. So it's very attractive. What is it in it actually for financial institutions? And I say scalability is a big factor, right? So being able to scale your demand up and down when it's needed is a big factor. You don't need to plan ahead your another year in order to purchase additional computer sources. This makes it very attractive for financial industry where requirements do change and you have to accommodate the change very fairly quickly. What else is interesting for the cloud? So I think the main premise for the cloud to make economical sense is pay as you go. What does it mean? A lot of risk management takes place overnight, and your traders, when they come in the office, your risk managers, when they come in the office next day, they want to see up-to-date picture. So big financial institutions, they do use a lot of compute resources, sometimes throughout all night, in order to compute these numbers and these measures. But throughout the trading day, these resources are often stand still, and this is where the waste is coming. Right. So ideally, if you are able to pay for what you actually use, this makes economic sense. It's also the hardware maintenance, right? So for big organizations to have a team of specialists to maintain hardware, it's not their core business. The core business is to serve their financial clients, but not necessarily hardware. Right. So what is actually the next big thing in this world? We made a solution. Let's assume we made a good progress changing infrastructure and transition from on-premises cloud/grid compute to public cloud, could be a third party, Amazon, Google, you name it. And suppose it works and everyone is happy, you've got the benefits described previously. So what is the next thing your traders and your risk managers will ask you? It's actually a life risk. So everyone wants to see their positions up to date throughout the trading day. And why is it important? It's important to make optimal business decisions. If market makes a sudden move, you want to be able to adjust your positions fast, so you're not losing money. So it's not about even saving the money from excessive expense on compute power. It's actually about not losing and making money. It's also to be ahead of competition. So if you're able to price and view the risk accurately, faster than your competition, you win business and you want to win right business. So what are your options to accomplish this using cloud? So you remember, you just finished the transition to public cloud. You now have your users asking for life risk. So what are your options to use cloud infrastructure and deliver on the requirements? So one option is always on cloud. So what does it mean? How does it? No, sorry, not always on, but on demand cloud. So as before, as using our batch task mode risk system, we would do. We'll try to use the same approach for our life risk. So is it gonna actually work? How does it actually work technologically when you're interested in fast response and low latency? What happens underneath when you send a request to price your portfolio? Your system needs to go and spawn new instances for compute. So going to Amazon or going to Google and actually loading instances with the right configuration. This takes time, right? So these first two steps, requesting instances, spawning all these instances, takes time. You also want to send all your market data and portfolio data to pricing nodes. This also takes time. And if you think about it, how much data a request to price simple interest rate swaps may contain, is a substantial amount of data shifting back and forth before you actually do pricing. So your quants and automatic adjoint differentiation can do a great amount of help for you to accelerate pricing and sensitivities. But if your infrastructure not ready for this, you will waste your time on shifting data around and not on what is actually interesting for your compute. So what's another interesting aspect is during turbulent market moves, many financial institutions will compete for the same compute resources. I don't know if you people actually think about it, but I think it's very crucial. You don't want to be in a situation when you're asking for new instances in order to compute risks and update your business decision makers on the measures, and you are refused to gain any new instances because other institutions in the same boat. So think of a price surge in Uber when you want to take a car back from theater. It may cost you more, and what is even horrible for your situation, they may cancel. So you may want to obtain a new instance to compute, but you will be denied. So you need to think about that. So what's another alternative here is always on cloud. So what is always on cloud? You provision your instances ahead of potential changes on the market, and you keep them running. So no time is wasted for provisioning, and it's a dedicated resource for your organization. You can also preload your portfolio data and analytics and potential historical scenarios, all these data sets that don't change throughout the day. And this can really help you to save really help you to improve latency and response time. But it can be very expensive, right? So every dollar you spend on cloud, you may be tempted to just throw money at the problem and purchase more instances as your business trades. But all these dollars are actually CO2. So how you can actually be ready for these requirements, for life risk that is coming? So we suggest to use automated adjoint differentiation in conjunction with the always on grid concept, right? What's the beauty of automated adjoint differentiation? It allows you to reduce the compute requirements by factor of hundreds, right? So even if you're in the mode of always on cloud and with bump and revalue risk measures or scenario risk measures, you would have to have thousands of nodes always available to you. With automatic differentiation, you can reduce these requirements substantially to make it a financially viable solution. So how does it actually work in practice? So in practice, everyone has some kind of risk system already. The risk system able to create and distribute jobs on remote compute nodes. And we can take advantage of existing infrastructure, and instead of computing a single PV on a remote compute node and exiting, dumping all these valuable trade definitions and the state, we can enable this node to stay always on and make a service computing PV and sensitivities on the fly throughout the trading day. Yes, so I hope I will be able to do, yeah. So one thing, this is where you can actually see a demo of this idea. It's a live risk service running on MatLogica.com, and it's not, it looks synthetic and fake, but it's not. It's actually uses open source quantity library with adjoint differentiation integrated. And in this example, we only cover interest rate swaps, but it's very easy to add nonlinear products. And here we demonstrate this idea. And the idea is we can preload 1000 interest rate swaps into a valuation graph, and this valuation graph can be optimized at runtime for valuation for quick response time. So every time we have an update on a tick data on market, we can very quickly and efficiently run the full valuation graph and compute PV of all trades. And what's most importantly, also we can compute all sensitivities, right? And in this example, it takes about 4 seconds for a single CPU core to actually load the trades into memory and form this valuation graph. But every single update on your portfolio view consumes only about 20 milliseconds. And to be honest, the server we're running this on, it's not very powerful. It's done by a single CPU core, so it's not a massive compute power behind it. And in fact, my notebook does a better job at this at the moment. So how does it actually work? Underneath, we have a very clever Runtime Compiler that allows our users to run their original analytics implemented in high-level languages such as C++ and Python, where they are responsible for the elementary operations. So if you remember, Luca was talking about expressions and elementary mathematical operations. Quant analysts are in control what kind of calculations take you from market inputs, be it the market rate, spreads, etc., to PV of a particular trade. We on the fly can record these calculations and form efficient machine code to calculate PV of the trade, taking you from inputs to PV. And also we on the fly can form machine code to calculate adjoint of this function or derivatives. And this typically means the code we generate, because it's formed at runtime, and it's formed to solve a specific problem at hand. We can do it much faster than the original program. I know it sounds magic, but it's not. Your program, when it's built by C++ compiler at compile time, cannot see all the details of portfolio you're going to price, right? But at runtime, you know what trades you're dealing with, you know its exact parameters, you know if it's a call put option, you know if it's a specific expiry and a number of cash flows in it. We're able to form machine code that can be run much, much quicker compared to compile time or ahead of execution compilation. Right. So I'm going to be fairly brief here. I don't want to bother you with a lot of details. If you head to MatLogica.com, you will see a lot of that. And we have some good publications around it. And what I want to leave you with, just simple message, that cloud compute is good, right? And cloud computing gives you a lot of savings, but plan ahead. Think what you would do for life risk. And in my opinion, to stay competitive and be cost efficient, automated adjoint differentiation is a must tool to have. And in fact, if you want to do it for life risk in the coming years, you might as well do it for overnight batch today. Yeah, and thank you very much. If you have any questions, I'm happy to cover that.